So continuing our discussion on radioactivity and radiation. So we remember that the cause is that unstable nucleus. And so, when the nucleus is unstable and it breaks apart, energy is released, which is a nuclear reaction, and then also there are three potential byproducts from that. And these are our three types of radiation. So the first is alpha. We use this symbol here, which is the Greek letter alpha. And so alpha particles and alpha particles we often see with bigger elements. So like uranium, like plutonium, when they have radioactive decay and the nucleus starts to break apart, alpha particles will be one of the first things that they'll pop out. And so an alpha particle is 2 protons and 2 neutrons. No electrons. So it's just 2 protons and 2 neutrons. And what you notice is that it is basically a helium atom when we're talking about. If you want to think of it, 2 protons, 2 neutrons. So you see it written alpha, top left, a mass of 4, and its number 2, indicating 2 protons, mass of 4, so 2 neutrons there. So that's an alpha particle. Big, and one of the things of note is that an alpha particle can be stopped by a sheet of paper. So an alpha particle doesn't have a lot of power to punch through something. So the second one is a beta particle. Well, let's call it beta radiation. Well, these are types of radiation, but it's a beta particle. Yeah, we'll go ahead. We'll stick with that. And a beta particle is essentially an electron. And so when we write it, it's you normally would see it kind of written with an E as a negative, indicating that that's kind of what's being kicked out. You will also see it written as this. Where you see beta with a -1 down there, indicating the loss of the charge, or essentially taking away a proton, taking away that one negative charge, but there's no mass to it, because an electron is so tiny that it has no mass. Similar to that, and you'll see this as well, it's kind of a variation of a beta particle, is what's called a positron. And that is basically positively charged electron. And you would see that written 0 for the mass, again, B, the Greek letter B, and then there's a +1 down there. And so that's beta, essentially an electron or a positron, a positively charged electron. And that can usually be stopped by what we commonly use aluminum as kind of the standard for that. The third is gamma radiation, and that's a ray. And so that's essentially a burst of pure energy. And when we write that, you'll just use the Greek letter gamma. And when we talk about what can stop that, it's concrete. And so, again, to go back, for alpha particles, you might see this written like a cluster of 4 circles representing 2 protons, 2 neutrons. Beta particle, just a tiny dot. And then for X-rays, because it's a burst of pure energy, you might just see a wave to represent that. So these are the 3 types of radiation that we encounter.